Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI MStat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So say problem number 3 says which of the following statements is or are true. So first one says for any real number r with modulus of r greater than 1, limit n tending towards infinity, summation I running from 1 to n, 17 into r to the n is equals to 17 by 1 minus r. So we have to check is it true or false. So first part say option the first question A. So limit this summation I running from 1 to n 17 into r to the n. This is actually nothing but 17 into r to the n into n, because this part nothing of comprises of I here. So this entire thing comes out of the summation, and just the summation just I running from 1 to n just applies on a constant 1. So it's and this thing this expression is this thing 17 into r to the n into n, right? Now this is actually nothing but infinity, right? Because if mod r is greater than 1, then limit n tending towards infinity r to the n is actually infinity, right? It properly diverges to infinity. So this thing is infinity, and obviously n also tends towards infinity. So this entire thing is infinity. So obviously this is wrong. 17 by r 1 minus r, it's not true. So the first question, the first A, question A is not true. It's false, right? Let's go to the second question. So let I be a positive square root of minus 1. That means I is basically iota here. And let x be any real number. Then tan x is equals to e to the ix minus e to the minus ix divided by I into e to the ix plus e to the I minus ix, right? So we have to check whether tan x is equals to this thing. So remember, from Euler's identity, if theta is a real number, then e to the I theta is actually cos theta plus I sin theta, where I is nothing but root over minus 1 iota here. So we know from the Euler's identity this is true. Therefore, e to the ix is actually cos x plus I sin x, and e to the minus ix is actually cos x minus I sin x. Here just replace x by minus x, you will get this expression. So e to the ix minus e to the minus ix divided by I into e to the ix plus e to the minus ix. Here it's going to be a minus sign, a minus sign. Yeah. So this thing just subtracting this equation 1 and equation 2, this first equation, second equation, we get this 2I sin x, and this adding these two, just using these two equations to figure out the subtract the difference of this and the sum of this. So this is 2I by sin x, and divided by I into this part is 2 cos x. So ultimately it's tan x. So second question B is actually true. Tan x can be written as this thing, so this is true. Now what about C? So C says that this series 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 and so on is actually less than 1. So let us see. So this thing, right? We have to check whether it is less than 1 or not. So let un be the general term. It's 1 by n into n plus 1. Okay. So we need to find the value of the series, whether it converges or it diverges, and if it converges, whether it is less than 1 or not. So basically the series, we have to find the series, right? So let Sn be the sequence of partial sums of the series. We know what is the partial sum, which is nothing but the sum of the first n terms of the series. So Sn is actually u1 plus u2 up to un. So it is nothing but summation r running from 1 to n. So it's nothing but summation r running from 1 to n, 1 by r into r plus 1. Now this thing can be written as 1 by r minus 1 by r plus 1, right? Can be written as that. It can be written as. So after running the sums, it's 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 and so on up to 1 by n minus 1 by n plus 1, right? So this thing easily cancel out. So minus half here, plus half here, then again minus 1/3, plus 1/3 is going to be the first term of the next term, so and so on up to this thing is also going to be cancelled. So ultimately the thing that remains is 1 minus 1 by n plus 1. So Sn is actually this thing. So limit of Sn is actually 1, right? Limit n tending to infinity, it's 1. So this is, we know that the sequence of partial sums is actually nothing but the approximation of the series. So limit of this thing is basically means that this thing is actually 1. So it's not less than 1, right? It's equal to 1. So question C is all false. It's not true. So till now we have A is false, B is true, and C is also false. What about D? So the function fx is defined as fx is equals to 3 cos 3x if x lies between 0 and pi by 6 and 0 otherwise. Is a probability density function. Let's see. So fx is this. So it can easily be found out that the curve of this function 3 into cos 3 is actually this 0 to pi by 6. It is something like this, because we already know how to trace the curve of cos x, and this is just change in the argument, replacing x by 3x and then multiplying it by 3. This scales the factor by a factor of 3, right? So it does have a curve like this. So this entirely, this is positive, right? So fx is not negative. That means if x lies between 0 and pi by 6, it is this thing, and otherwise it is 0. So ultimately fx is not negative, right, for all x. So one of the conditions is true. For pdf we need to check two conditions: whether the function is not negative or not, and secondly whether the function integrates integrate to 1 or not. The entire area of the function, it should be 1. So the first property is satisfied. Fx is not negative for all x. So this is good. So what about the second? So integral over the entire real numbers fx dx is actually integral over 0 to pi by 6 fx dx, right? This integration is very easy, so it is nothing but 1. So it turns out that the integration is also holding true. So both the properties hold true. Therefore, fx is actually a PDF indeed. So option D is true. Therefore, option B and option D are true, and option A and option C are false. So yeah, there you have it. It was a very easy problem. So yeah, there you have it, the solution to this problem. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.